Welcome back to Harburn Double O, or indeed, welcome to Harburn Double O. In today's video, I'll be going through the ESP32 setup with servos. It's been a bit of a learning curve for myself, and I did manage to damage my Freenove board in the process of making this video, so I've damaged 2 ports. Still work to a certain extent, but so this one does work with 4 servos. I've tested 4 servos, even though the 2 ports are slightly damaged, it still works. On this other note, this board here, this is one of the boards I got earlier. This is one of the boards without the 0 or GP0 on it, so you can only use 3 servos on it. What I'm finding with it as well is when the servo moves, it stops and the power doesn't go off. Now, if you've got your layout there with quite a few servos in it all powered up, it's going to be a problem for you. Could be drawing quite a lot of current. Whereas the Freenove board, when it moves across, after 2 or 3 seconds, probably a second actually, the power goes off with it, and that's what you're looking for when you're doing your servos with your ESP32. You don't want the power on all the time. So I'll take you across the computer and I'll show you something called mapping first. Something new on Rocrail, so you can actually map the pins. So I'll take you across the computer there and show you that first, and then we'll show you how to set up for servos. So, in WIO, click on WIO. I've only got one board plugged into the computer at the moment, and that's board number 62. So I highlight that board there and I'm going to IO mapping. Now, in IO mapping, I'm a relatively newcomer to this, folks, and it's only my opinion. Please do go to the wiki, Rocrail, because that's the only official bit of information for Rocrail is the wiki. But when you first go into it, it goes in there and checks all the pins to see what address is assigned to. So for example, GPI 0 is assigned to pin 1, GPI 4 is assigned to pin 2. GPI 2 is assigned to pin 3, and GPI 12 is assigned to pin 4, and so on. Now you can change them to suit what you want. Bear in mind, unlike the PyCow, the pins are not in order, i.e. 1, 2, 3, 4. Pins are all over the place on most ESPs I've found. Down the bottom, we've got IC2, SPI and UART. These pins are all frozen. You can't get in to change them. Across here we've got servo. Now on the ESP, forget this part here. If you put ESP servo 1 to address 12 and program it in address 1 for the servo, GPI 12, it won't work. You put in address 1, you need to put in GPI 0 for the Rocrail to move the servo. So again, you can change it, but don't make the mistake by having 2 number 0s or 2 number 19s and so on. Once you change it, if you want to change it, click on set, and then you need to reboot for the changes to take effect. And then that means reboot the ESP32 module. So that's mapping, folks. Go to edit panel, and we're going to set up a switch to work via this servo. So I'll click on that, drag it across, close that back down again, and I'll go back to track plan and switch on to operate. The reason being, if I click here, it doesn't add another switch, as I found out my mistake. We're going to set up the servo first with this switch. Right click on top of it, click on properties. On general there, you can call it what you want, and the decoder what you use is the WI62. For this panel here, that is it. We don't change anything else at the moment. Why? Okay. Right click again, now we're going to set up the interface. So in the interface there, ID, WIO, and node, it's a board number, board 62, and the address we're going to put in there is address 1. That'll be on pin GPI 0. Port, we leave blank parameters. This is how far the servo moves left or right. You have got the bar chart up here, which I don't like using. I like to put in numbers. So we'll start off with 40 and we'll put the other one at 110. This is how far the servo moves left to right. Then you can fine tune it to set your servo. Down the bottom, what's switch time? The moment it's set to 500, I find that quite fast. It's actually speed the servo moves. You set it between 1 and whatever number you want, up to, I think it's 999, but I like to set my servos at 20. Anything between 10 and 20 is a good speed for your point motors to move left or right. I declick the accessory, I click on servo. Once I've done that, I apply OK, that's us. So before we move on to the camera part, we're going to set up my schematic and I'll show you the wiring, the schematic. So this is the little wiring diagram there, folks. This is the servo here, pin 1. Normally with most servos it's an orange wire, specifically with the Tower Pro SG90s. So that goes into a resistor, 270 ohms, and then into the pin on the ESP32. Pin 0 being for address number 1. I know it's a bit confusing, but once you get your head around it, it's not too bad. It's quite important you put this resistor in. Remember at the start of the video, I says I destroyed or damaged 2 pins on the chip. The reason being I left this resistor out. 5 volts had a little surge and it interfered with the board itself. So definitely put your 270 ohm resistor in line with your pulse width modulation. The middle pin, pin 2, is normally a red wire, certainly on the Tower Pro SG90s. That's your 5 volts. You better with an external power supply for the servo compared to the ESP32. 5 volts, between 5 and 6 volts is more than enough for any servo. And the last one, the green, the number 3, saying green, it's not green, usually a brown wire on the Tower Pro, that's your ground. Now with the ground, you can share the ground, you can tie the ground into the ESP32 and also the servo. That's what you call a common ground. Certainly no need for it with the servos, but you start going to the other devices there, sharing ground, it's not too bad an idea. That's a wiring diagram there, folks. I'll set the camera, I'll get it wired up and I'll show you how it works. I've got the board set up here, folks. I've put this pin into pin 0 on the board. I'll take that into the resistor, 270 ohm resistor. For my servo, I've got 3 leads in it. My black is for ground, so I put the ground to ground on the board. The red is for power, so I put the power into the 5 volt bus rail on the board. Get it all twitch from the servo as the power's in. I certainly recommend when you're wiring these things up to have this board switched off. This is only for demonstration purposes. The orange wire from the Tower Pro is the signal. It goes to the other side of the resistor. In there. If I go back to the Rocrail, I start to operate the power servo, just make sure it's in operate. First time I click it, it moves. Next time I click it, it moves back. So that's it, moving left and right to suit. You can invert it, you can change how far it moves left and right. Just to show you the board there, folks, number 4, you see the little light is on there. It's not quite bright, but if I move it to that pin, number 4, which is address 0, and I change the settings in Rocrail properties, go to the interface and I set to address 2, apply, OK. So now it's address 2, it still works, even though the little light is on, but it is damaged to a certain extent there, folks. I don't know if I reprogram the board, this little leakage will go away. I've tried tying in a pull-up resistor to make it high, and I've also tried a pull-down resistor as well to make it low, to no effect. I have got another board, but I don't like using too many boards because they cost money. So I've got too many boards been damaged. So that's us, folks. In the next one, I'm going to show you a MOSFET and also a relay as well. So hope you enjoyed it, folks. Please leave a like and if you want, subscribe as well. And of course, any comments would be freely welcomed, good, negative, bad or indifferent. Thanks for watching, folks. Catch you again.